In this problem, Penn draws a triangle with one 90-degree angle, right? What could be the measures of the other two angles in Penn's triangle? Well, let's just sketch this out for a second. If we have one 90-degree angle in a triangle, we call that triangle a right triangle, and we use this symbol right here to show a 90-degree angle. Now, what's nice about a triangle is that you know that whatever these other two angles are, when you add them, let's say this is angle A and B, when you add the 90-degree angle and whatever A and B are, you have to get 180 degrees, right? This is a really fundamental property with triangles, that whatever shape your triangle, as long as essentially that it's on a flat surface, if you add up these three angles, you always get 180. So what they're really asking us is, if you know this is 90, what could the other angles be? And I want to cross out D and B, right? And I want to cross out C even before I start, because it's not possible to have more than one 90-degree angle in a triangle, right? If this angle is 90 degrees, and let's say A is 90 degrees, well, that's already 90 and 90, right? 90 plus 90 makes 180. So this other angle, whatever it would be, would then have to be 0 degrees, and that doesn't make sense because a 0-degree angle doesn't even open. So there's no way you could have two 90-degree angles, because then you're out of degrees, right? Try and build a triangle from two 90-degree angles, and you can just see it. If I have one 90-degree angle, and I have another coming up like this, right? How would you even close this triangle? You'd have to add more lines to it to bring this back together, and that's no longer a triangle, right? As soon as you have these two 90-degree angles, you can't close the shape. So B has a 90-degree angle on top of the original, so that's out. C has 120, which is even worse, right? That's even larger. And D also has a 90-degree angle. So A has to be the answer, and if you check it, A is the only one, choice A, where if you add 30 and 60 and 90, you get exactly 180, and that has to be the answer here. Of course, you can extend this, and shapes with four sides, well, we can do it right here. If I close this, no matter what the four-shaped side look like, as long as it's kind of a polygon where it's closed and the lines aren't curved, you're going to get not 180, but 360 degrees. In fact, every time you add one more side after that, the amount of degrees inside your shape goes up by 180. So, and so next we have a five-sided shape, 1, 2, 3, 4, 5, and this will have another 180 degrees or 540 degrees on the inside. And this just goes to the idea of triangles, because really a rectangle or a four-sided shape can be thought of as two triangles. So two groups of 180. And then here we can have three triangles, or you can just draw them. Let's fix that. 1, 2, right? 1, 2, 3. These three triangles each have 180 degrees. So overall, this shape will have 180 times 3, or 540 degrees. And really what we're just doing is counting the number of triangles that we can draw from one point to another in the shape, and that allows us to go further on and count those angles. That's something to look forward to in the future. All right, thanks.